Hello, my name is Julio Casablanca, and I am a Palo Alto Network Technical Instructor. Today, I am privileged to share with you basic routing concept, routing protocols, and routed networks. The objectives for these tutorials are simple. First, we define routing. Second, we will define static routing and static routes. We will then define the requirements for dynamic routing. RIP or Router Information Protocol and OSPF or Open Shorter Path first. The very first thing we would like to define is the concept of routing. By now, you should have gone through the Layer 2 tutorial or the switching tutorial. Routing or Layer 3 communication is based on logical IP address. And we actually use a numbering convention very similar to what you see right here. In fact, it's just like this. That one right there and that one right there. Notice that we are using the third number, the third one of them, to identify the network. This one right here is different than this one. So 10.11.1, it's a completely different network as 10.12.1. That's what we use each one of these segments, which we call octet, to identify your network. Now, in routing, the whole idea is to carve out logical networks. In this particular area, we have two networks. We have the first network here, the second network. And the router in the middle gets to be the postal man. So whenever local traffic gets generated, it will stay within a network from computer A to computer B. And then whenever traffic that does not belong to network 1 is generated, then the computer would then send it to that interface, that IP address in that router, whose sole job is to keep a table, and we call it the IP table, which knows in which interface each network is located. So basically, it's your postal service. It is your postal service. A packet shows up here. It will look at the table and determine which direction does it go. In this case, it will go that direction. Okay, just to recap, a router and routing. A router is an appliance that executes the routing. And routing, it's a logical concept where we traverse from one network to another network. For router to exist, you must have two or more logical networks. Let's get started with the basics. When a packet generated at a higher layer application, it could be your Microsoft Word processor, it could be an email. Once it's generated and you hit send, it will get pushed down the OSI layer into your network interface card. The NIC has already been pre-configured, and typically when you configure the NIC, you will give it its own IP address, you will give it the mask, and these two will tell you which network you belong to, and then you're going to give it a default gateway. The default gateway happens to be the IP address of the interface, which takes care of your network. So it'll be the IP address of the interface in the router, which actually takes care of the network that you belong to. Now, whenever a packet comes here, and if it turns out the destination of that packet, it's a network within your network, Then it will simply send it to the switch. It will arrive to the computer, and then the computer will reply to it. If the computer here, if your computer right here doesn't know what is the MAC address or the physical address of that particular computer, even though it realizes it is in the same network, it will use a protocol called ARP, Address Resolution Protocol. So think, for instance, let's just say that this happens to be the local area network, the network that represents this switch right here, this computer and this computer. And you happen to be sitting here, and there's a lot of other people sitting right here next to you. So if this were a street, and you know the logical address of this guy, but you don't know the house number, you simply get out of the door of your house and you say, where does Mr. Casablanca live? His logical address is the house of Mr. Casablanca. I just don't know the house number. So I scream down the street. I start screaming, where does Mr. Casablanca live? Is this guy Mr. Casablanca? No, he will ignore it. If this guy's Mr. Casablanca, no, he will ignore it. If this guy's Mr. Casablanca, no, he's going to ignore it. If this guy's Mr. Casablanca, if the answer is yes, I'm going to scream back to him. I'm going to reply, I am Mr. Casablanca. By the way, my house number is 501. So he will learn the IP address. He will build a little table, which is called the ARP table. And from that point forward, it will send all the traffic direct, and this guy's going to reply to it. Now, there will be times in which I will generate a packet that whose destination happens to be another network on the other side of the router. So it will be a completely different logical network. So as I actually request to find out using ARP if anybody on my network knows that address, I will get no reply. I have no option but to send that packet to that port, which is what we commonly refer to as a default gateway. The router will take a look on its IP table and figure out which direction to send it. So if this is network A, this might be network B, this might be network C, this might be network D. Right here on this table, depending upon the destination address, it may very well go to that network, it may very well go to this one or that one. That is the first step. That is the basic interaction between your network interface card and the rest of the network. It's important that you understand that. So one of the things that we have to keep in mind when we're talking about layer 3 or routing or IP routing concepts, and as you saw previously, we do have a routing table. We do have, in fact, it's known as the IP table. So if you were to have a router right here, and this will be your very first network, so we're going to call this network 1, and we're going to call this guy here network 2. So you in essence have two network, and your intention is to traverse from this network to that network, and from this network to that network. The name of the game is building that table, building our IP table. And we have two possibilities to do that nowadays, today. We can do it manually, which is the oldest way to do it. And then once we did it manually, we had some improvement on top of that. Or we can do it dynamically. Those are the two techniques to do it, to build this table here, or the postal service actual service. So when we do it manually, we actually do it manually. We configure, when we configure the appliance, we tell it, IP address, static route, and we point to a specific interface. So if you were to look, and let's just again draw the router, this happens to be the LAN where you are located. So I'm going to put here you, representing you as an individual. And then we may have here another interface for another network. So this is going to be the very first target, T1. We're going to have here another network, which is another computer. We're going to call that target 2, meaning you're going to generate a packet here, and the very first one will be destined to T1, the second to T2. If you take a look at this, logically, you have network 1, you're going to have network 2 right here, and you're going to have network 3. So on your table, you got to set up manually a specific IP address or IP table that says if you're going to network 2, go out this interface. If you're going to network 3, go out this interface. And if you want to go to network 1, go out this interface. You have to build that manually. Dynamically is when the routers, in case you have multiple routers, actually have the capacity to find each other. So the router, as soon as you activate the dynamic process, and that little drawing represents the process, can either just advertise through all the ports and say, I am a router. And once they find each other, so this guy will find that guy, this guy will find that guy, they will start exchanging routed information. They will start exchanging the tables, information about all the routes that this router found. So this router out of the gate is going to find that route because it's attached to him, this route because it's attached to him, and this route here in the middle, that network, because I'm attached to it. This router here is going to find that, and this one as well because we're attached to it. So this guy table, dynamically, he's going to learn if I want to go to network A, B, C, and D. So he's going to conclude that if I want to go to network A, I have to send the packet into this network so it can hop in here, hop in there. The same thing, if this router wants to go to network, if this router here wants to go to network D, he knows that he has to go here to go there, but it happens dynamically. You don't have to type it manually. So we will discuss the manual routing. We will show you an actual emulated demo on how to configure that. We will then discuss the advantage and disadvantage of manual routing and why we went to dynamically.